The last part of 9.3 is called Differentiation of Trigonometric Function. And for trigo, we're gonna have 6 different functions. So let's start with the first one, which is fx equal to sine x. If we differentiate this equation, when we differentiate fx, we will get f prime x. When we differentiate sine x, look at sine here. When you differentiate sine, you will get cos. Whatever function you have here, just copy this down. Next, you need to differentiate this function. So when you differentiate x, you will get 1. So you'll get cos x times 1, and we can just actually ignore 1. So it is just cos x. Next is fx equal to cos x. Differentiate fx will give you f prime x. Differentiate cos will give you negative sign. The function x stays the same. But don't forget to differentiate this function. So when you differentiate, you'll get 1. As per usual, we can just ignore 1. And hence, when you differentiate cos x, it is just negative sine x. The third one is fx equal to tan x. Differentiate fx will give you f prime x. When you differentiate tan, you'll get secant square. The function x stays the same. But don't forget to differentiate x. So you'll get 1. And we can just ignore 1. And hence, when you differentiate tan x, you'll get secant square x. Next is fx equal to secant x. When you differentiate fx, you'll get f prime x. When you differentiate secant, you'll get tan times secant. The function x stays the same. But don't forget that you still need to differentiate the function x. So you'll time with 1. And we can just ignore 1 as per usual. And hence, when you differentiate secant x, you'll get tan x secant x. The fifth one is fx equal to cosecant x. When you differentiate fx, you'll get f prime x. When we differentiate cosecant, we will get negative cotangent times cosecant. The function x stays the same, but we still need to differentiate the function x. And we will get 1. And as per usual, we can just ignore times 1 here. And hence, when you differentiate cosecant x, you will get negative cotangent x times cosecant x. The last one is fx equal to cotangent x. When you differentiate fx, you'll get f prime x. When you differentiate cotangent, we will get negative cosecant square. The function x stays the same. But don't forget to later differentiate the function x. And we will get 1. So just ignore 1. And hence, when you differentiate cotangent x, the answer is negative cosecant square x. So these are the 6 derivatives of trigonometric function. Usually, all 6 will be given in the exams, but I think it's better for you just to memorize the first 3 here, just in case it is not included in the exam, which is quite easy. When you differentiate sine x, you will get positive cos x. When you differentiate cos x, you'll get negative sine x. When you differentiate tan x, you will get secant square x. So try to memorize at least these 3. The other 3 here will usually be given in the exam. So let's do example 13, where we need to find the derivative of the following function. For question A, we have y equal to sine 2x squared plus 8. So now here, the function is no longer x. This is a function, and let's call this function as u. So we will get y equal to sine u. So we will differentiate this function. Differentiate y, we will get dy over dx. Now let's differentiate sine u. So we need to differentiate sine. So in the exam, usually you are given this equation. Since we need to differentiate sine, We will look at the first one here, since this means differentiate sign. So you can see that when we differentiate sign, we will get cos. And hence here we're going to have cos. The function u stays the same. But don't forget that we still need to differentiate u. So you'll get u prime x at the back here. So we need to substitute u and u prime x in this expression. So we know that u is 2x squared plus 8. Therefore, u prime is 4x. So substitute both into this right hand side here. So we'll get cos 2x squared plus 8 times 4x. And hence the final answer is 4x times cos 2x squared plus 8.